What is the difference between direct current and alternating current? By KayScience.com. Direct current is also known as DC. To explain what a direct current is, we have a very simple circuit here, where the cell pushes the electrons out of the negative terminal. The electrons flow around the circuit in one direction only. There is only one direction for the electrons to take, so this is a direct current. A direct current is where the electric current flows in one direction only, and this normally happens in circuits powered by cells and batteries. An alternating current is also known as AC. To explain what an alternating current is, we have the same circuit, but instead of there being a cell, we have an AC power supply connected to the mains electricity using a wall socket. In an alternating current, the electrons move back and forth repeatedly, constantly changing direction, represented by the electrons with two arrows next to them in opposite directions. So an alternating current can be defined as when the electric current is constantly changing direction. This means the electrons repeatedly flow in one way and then the other way in successive cycles. It's question time. Attempt these questions to check your understanding. In a direct current, also known as DC, we can see how the electrons flow in one direction. To understand a direct current in more detail, we can use an oscilloscope. This tells us how the potential difference changes with time. In this graph, we can see how there is time on the x-axis and potential difference on the y-axis. The positive symbol shows the potential difference in the forward direction, and the negative symbol shows the potential difference in the backwards direction. The oscilloscope shows how the potential difference is a flat horizontal line in the forwards direction. This backs up the argument that the direct current is when the electric current flows in one direction only. As the line is flat, it shows how the potential difference does not change, whereas an alternating current, known as AC, is where the electrons oscillate back and forth. They do this repeatedly, constantly changing direction. The electrons never actually flow around the circuit. The energy is transferred as the electrons oscillate back and forth. Here's another graph to show what an alternating current looks like on an oscilloscope. On this graph, we already know on the x-axis is time and on the y-axis is potential difference, where the positive sign represents the potential difference in the forward direction and the negative sign represents the potential difference in the backwards direction. An alternating current on an oscilloscope looks something like this, where the potential difference increases, then decreases, then increases, then decreases, and so on. This happens over and over and over again. The reason for the shape of this graph is when the potential difference is increasing, the electron is moving forwards. When the potential difference starts to decrease, the electron is moving back towards its original position. When the potential difference is at 0 volts, the electron is back at its normal position. As the electron continues moving backwards, the potential difference continues to decrease. When the potential difference starts to then increase again, it's because the electron is moving forwards and back to its original position. These cycles of movement happen over and over again, as the potential difference repeatedly changes direction. It's question time. Attempt these questions to check your understanding. Let's look at an alternating current in more detail. From this diagram and the previous explanation, we know that electrons oscillate back and forth. How many times these electrons oscillate in 1 second is the frequency. I'm using this pen to model how the electrons oscillate back and forth. This means how they just move back and forth, and they pass on the potential difference as they move back and forth. In the UK, the mains frequency is 50 Hz, as the electrons oscillate back and forth 50 times in 1 second. We're now going to look at an oscilloscope graph for an alternating current, where the mains electricity is 230 volts. These dashed lines represent how the potential difference reaches 230 volts in the forwards direction and 230 volts in the backwards direction. In this graph, the peak potential difference is 230 volts, and this is the difference between the highest level of the wave and the middle level of the wave. From the peak of this wave to the peak of this wave represents one complete cycle. Or another way of defining one complete cycle is from this point to this point. This also represents one complete cycle. So now your task is to calculate the frequency using this graph. The equation to calculate frequency is frequency equals 1 divided by time. So to calculate the frequency, we need to know the time taken for one cycle. The graph shows how one complete cycle is from here to here, or you can also do it from here to here. And either way, the time for one cycle is 0.02 seconds. As frequency equals 1 divided by time, we write frequency equals 1 divided by 0.02 seconds. The frequency equals 50 Hz. This means the electron oscillates back and forth 50 times in 1 second. Now for your exam, you could be given different data, so don't assume your answer of frequency will always equal 50 Hz. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.